Good to have you here. Thank you for that. Thank you for spending like the next 45, 60 minutes with us, SAP. I'm going to talk about today how we can accelerate delivery of next generation data-driven business outcomes. Well, first of all, what I would like to do is to talk a little bit about, well, what are we seeing is happening in the data space. Before I go there, maybe I should introduce myself, right? I totally forgot about that because I'm seeing some known faces in the audience. My name is Gerd Danner. I'm working for SAP for 21 years now. In that time, I had various roles at SAP, working in development, working in consulting, working in product management. That's the beauty of a large company. You can have many different roles. There was like one common thread in my career, that was I was always dealing with data. When I started at SAP, I was kind of exotic in doing that because SAP was all around business process, all around enterprise applications and business process. So that's our heritage, and that's good. But SAP has changed a lot in the last 20 years. We have added to our portfolio market-leading BI solutions. We have added to our portfolio database and data management platforms with the HANA platform, and so on and so forth. And that has happened for a reason. If you're looking at what is happening in the industry, every single company I talk to these days is in some way, shape, or form in a digital transformation. Now, what has happened in that digital transformation stage is that more and more we realize this is all data driven, right? And why is that? Because we're seeing some major shifts in what's happening in the data area. Three core trends that I'm seeing. Number one, all of a sudden, data can be stored almost limitless at an affordable rate, right? When I started in development in SAP 20 years ago, we had an exclusive club. It was called the BW Terabyte Club, and we had 20 customers worldwide that were part of that club because they had 1 terabyte in the system. Nowadays, we're talking about petabytes. A terabyte is a laugh. I have that at home many times. Secondly, what we're seeing in the data space is we have more data available than ever before, right? Everything is creating data, right? We as consumers, we create data. We carry mobile devices, that creates data. We click on web pages, that creates data. Every device in the real world is connected via sensors to the internet, creating data. So more data than ever before. And we can store it. Plus, what we're seeing is that now the machine learning and AI algorithms that partially we had for many, many years now all of a sudden make sense because we can train them with that data that we have, and we can use the results, we can use those business outcomes to drive business. And that is what is happening right now. We are basically from the digital economy moving to what we call the intelligent enterprise, basically helping our customers become truly intelligent enterprises by leveraging human and machine intelligence in order to drive better business outcomes. Now, what are such business outcomes that are data-driven? And let me lead here with an example. That's an example taken from a car manufacturer. You might not recognize that immediately. What's happening on that picture is that is a windshield molding process. Basically, in a car, you have a windshield. That windshield is like a bent shape, right? A bent piece of glass. In order to get it in that shape, you take a flat piece of glass, you apply heat, you apply pressure, you put it into a molding oven where you keep it a certain time. After that, you take it out and you have a windshield. Now, even though, and you can take that from that picture, that manufacturing process in that organization was very much automated. You don't see any humans in that manufacturing process. All they could do from a quality management perspective was probing. Right, so they had a lot size of 100 windshields. After that lot size got produced, they picked randomly two, broke them, and based on how it breaks, they could tell good quality, bad quality. So where they wanted to go to, actually, from a next generation business outcome perspective, now the clicker is no longer working, is they wanted to have a smart quality application that could tell them in real time for the individual piece of glass that was currently molded into a windscreen, whether that was of good quality or bad quality. In order to get there, what they needed to do is to combine a variety of data inputs. Data inputs coming from complete different areas. A data input coming from an infrared camera where they took a picture of that windshield during the process. A data input coming from an IoT pressure sensor where they basically figured out, do I apply evenly and the correct pressure? And also data coming from their ERP where they had the correct manufacturing conditions in that ERP. And only by combining all three and only by then applying machine learning and predictive, right, they could actually get to that business outcome. Now, the challenge that they were facing in that, and you see that on the next slide, they started to engage in that in a kind of POC setup, and they started experimenting, installed a camera, installed a pressure sensor into their production line, started collecting that data. The infrared images went to a Hadoop cluster where they did some R processing of the images, right? Pressure sensor through a Kafka streaming engine. But then what, right? They struggled basically getting this whole thing into production. They struggled getting this beyond the experimental stage and connecting the different bits and pieces, connecting the IoT data with the infrared data, connecting the ERP data to the IoT data, and so on and so forth. And in the end, right, the application was not ready for production. It could go in an experimental stage, but not beyond that. And that is something we are commonly seeing in our customers. And the reason for that is because it is not easy to master all of those technologies that are typically involved in such a business outcome scenario where you combine enterprise data with big data. You have to deal with open source technologies, Python, R, Kafka. You have to deal with Hadoop. You have to deal with enterprise data, and so on and so forth, right? So that actually makes it challenging and difficult. Now, when we engaged, we helped them rationalize and streamline that architecture, right? We still basically keep core parts in the architecture. We are not challenging the Hadoop cluster at all. You could also exchange Hadoop in that picture with any cloud data store like Amazon, Google, Microsoft, right? So infrared image data still goes to Hadoop, pressure sensor data still flows through Kafka, but what we managed is to help them build those data pipelines, that actually help connect data of a variety of types, data of a variety of storage locations with the machine learning, which by the way still remained with their open source approach that they had in order to create the business outcome that they were looking at, right? And in the result, right, by having that single model of the application and by having that strong link through the data pipelines, they could get production ready with that application. Now, if I step back for a moment and see, well, what are the challenges we are seeing in data management besides, well, I said data availability is there, data storage is there, we can make sense out of it, but there are challenges still. We are seeing basically data sprawl happening. Data is not in a single location anymore. Data is basically separated over several clouds, over several on-prem environments, and it's getting increasingly harder to actually get into one single place, right? That leads to data being less accessible and us having, even though we have more data than ever before, actually having a lesser understanding of things like what is a customer, what is a product, and so on and so forth, right? In data management, when you create analytics, when you create AI and machine learning, we're seeing that mode 2 innovations that are actually driven by business, innovations that are driven by data scientists are actually emerging rapidly and superseding innovations coming from IT. Now, these two things cannot be treated completely separately, though. Right. What I'm seeing a lot is that BI competency centers drive data warehouse development. Business is innovating on top. That innovation brings things that should actually make their way back into the data warehouse. Right. So the question always is, how can I run these mode 2 operations next to my mode 1 developments and also refactor them, integrate them at a later point. We are seeing that data in motion analytics emerge and complement traditional ways of I load data to a data warehouse, then do the analytics on top. What is a data in motion analytics scenario? Think Uber, right? If you're looking at the Uber app, everybody I think has used Uber at least once in their lives, right? If you look at that app, you see basically the taxi is going to arrive in 3 minutes, right? How does that work? The taxi sends a constant feed of geolocation to the Uber server. The Uber server, based on traffic information, weather information, whatever other information they take into consideration, basically predicts what the arrival time will be and send that information to the front end. All that information doesn't get stored. Why should it, right? It's basically data that is being processed on the fly. That is data in motion. Again, what makes this challenging and complicated is that in order to deliver on an end-to-end business scenario, you quite often have to deal with both data in motion as well as data at rest. And in order to manage and process that, right, again, you either have to master 20 different technologies or you have basically an orchestration capability that helps you get that under good control. Then we're seeing that legal risk obviously is increasing. We're seeing that with GDPR, for example, General Data Protection Regulation from the EU, there's all of a sudden cost associated to breaking certain compliancy rules. Big cost, right? So people are concerned and have to factor that in. And I talked about the difficulty of operationalizing data science already. That's definitely also a challenge that we see, right? Now, what does that mean when we reinvent things like data warehousing or creating a data platform for creating these next generation business results, business outcomes? As I was saying earlier, like next generation business outcomes like customer retention insights or predictive maintenance, trade promotion effectiveness, there seems to be one common pattern that I'm seeing, that those results, if you want to create them, you typically have to combine enterprise data, so data that is sitting in your ERP or in your CRM or in your procurement solution. You have to combine that data with data that is coming from the big data world, IoT data, consumer signals, web log information, whatever that is, right? And while enterprise data comes from those enterprise application systems, big data is sitting on Hadoop, on Azure, on AWS, on Google. Now, if you talk especially to the people responsible for that big data world, and if you ask them, well, can you help me solve that problem? The common answer is yes, sure, just tuck it in. Just load the data into the data lake, right? And once it's there, we can do all the magic, right? The challenge that I see with that, you see on that slide, what does that do to agility? I mean, I said storing data doesn't cost a thing, right? But as soon as you take a copy of data and you put it into a schema, right, it will become a legacy, right? Why? Because your business changes. When your business change, you have to potentially adapt those models and schemas. That means you have to realign those data sets that are stored somewhere, and that is creating processing, and that is creating cost, right? Security, next thing, right? The more copies of data you take, the more places you have to make secure for unauthorized access, both from internal as well as from external, right? So if you have more copies of data, that will also create more costs. And last but not least, from a compliance perspective, if you copy customer data into 100 different places, from a GDPR perspective, you have to make sure you know where it's stored, you have to know how it's being used, and you have to be able to delete it if somebody is requesting to be forgotten, right? And that, again, is getting increasingly complicated the more copies of data you actually take. Now, how do we approach that? From a modern data platform perspective, we believe the starting point already is on the application side. Starting point already on the application side, where we move all our applications onto the HANA platform. Right? Why do we do that? Because that gives us the opportunity to push down operations that prior to that were happening on the application layer directly to the data layer. And that will help you basically increase speed and agility of those applications. We can do things like running an MRP, material resource planning, now in seconds instead of hours, for example. So that's great. Also, what it gives us is that we can do reporting directly on those applications. Right? Each and every application basically comes now with what we call HANA Core Data Services, which are basically reporting views we have in our applications as like pre-built content, and you can run operational reports, you can run planning processes, even like prediction AI directly on those application databases, removing in some cases the need of replicating that data into a data warehouse. Right? Now, secondly, we believe there's definitely still a need for a data warehouse, right? A data warehouse where you can actually integrate data across different data sets. Now, the way we approach data warehousing from SAP is like with a two-pronged approach. We on one hand side, say we have an application-centric approach with our BW strategy. BW has been around for 20 years roundabout. The big asset that we have with the BW is the business content that is integrated with the SAP application. So if you need to create data warehousing on SAP Finance, on SAP Logistics, it is a very good starting point that will accelerate and speed up delivery of your project. Now we are also seeing that a lot of our customers actually have like SQL style data warehousing, where they use whatever modeling engine to build out a data warehouse infrastructure, load it up with Informatica or with data services from SAP, and put some reporting on top. Right? Now, if you want to consolidate that on a single platform, if you want to consolidate that on HANA, you can easily do so. We have a scenario where we can basically attach to the metadata of those third-party data warehouses through Enterprise Architecture Designer, our modeling environment, do a refactoring of that metadata into the HANA database, while you keep the data logistics, the ETL processes, pretty much in place. This way, we have proven with many customers that we can basically take an Oracle data warehouse or an IBM data warehouse or a Microsoft native data warehouse very quickly into SAP HANA. Now, the question, why should you do that? Well, first, you're running on a single platform, SAP HANA. Second, you can integrate then very easily between the BW, SAP-centric data warehouse, and the non-BW, the SQL-style data warehouse. Number three, what it gives you is what I call the HANA advantage. Since HANA is an in-memory database, right, you can calculate data on the fly. You can integrate data on the fly. You only take copies of the data where absolutely necessary, right? Basically, just the inbound landing page, landing table would be like physical store, while everything on top can be calculated views. Now, last but not least, in order to connect then this single, say, access area for all the enterprise data that you have with BW, with HANA native data warehousing, in order to connect that to the data lake, that's where SAP Data Hub is coming in. SAP Data Hub that allows you to connect from enterprise data to the data lake, that allows you to create those data pipelines that take in data from a variety of data stores, a variety of data types, combine that with prediction, AI and machine learning coming from SAP with Leonardo, but coming also from open source like Python, R, and put the results then into the consuming applications via APIs. Right? So we can consume that through Analytics Cloud, we can consume that through our own applications, through certified partner solutions. And that is giving us an agile way of managing data. Why agile? Because we don't take copies that are not necessary. That means if you have to change your business, you can quickly change your business. As a starting point, we don't have to move all the data into a single place before we can start doing a business scenario. We can simply just create like a meta view on the data and start processing the scenario immediately. It is secure because from the enterprise data perspective, we leave it where it is. We are not replicating enterprise data that is typically critical from a security perspective into a data lake where trying to recreate the security that you have on the enterprise side is not that easy, right? And it's also compliant. We avoid unnecessary copies of data. We provide you with data cataloging, data lineage capabilities that would tell you what data is stored where, so that you can actually also successfully delete it if you need to. Now, let's zoom in a little bit more on what is behind that. One of the core components I was mentioning is the SAP Data Hub component. SAP Data Hub, again, allows you to connect to a variety of data stores, process a variety of data types, completely unstructured, semi-structured, also enterprise data, which is stored in databases, which is completely structured, right? And feed that into machine learning, into data refining applications. Core capabilities that we're having in SAP Data Hub starts with the data discovery, the data governance piece. This helps you understand, well, what is the data that I have available in my enterprise in the first place, right? Now, data cataloging is not new. Right? What we are doing here is we are taking it to the next level. Data cataloging, like traditional data cataloging, is very much a manual process where people sit down and basically type into a data catalog, this is a customer and this is how it is defined and these are the information policies, how I want to manage it, and so on and so forth. This works perfect in the traditional enterprise world. In big data, it doesn't work any longer because you have people just pouring in data into the data lake all the time. You need to automate a lot of things. You need to automatically catalog, you need to automatically understand, you need to automatically also evaluate the quality of your data to get an idea what you can use it for, right? That's basically what we're doing in SAP Data Hub. Secondly, with Data Hub, we help you build out those data refinery applications, those applications that take the infrared picture, that take the IoT sensor signal, that take the enterprise data and prepare that in a way that you can train a machine learning algorithm on top. And once you have trained your model, do the same thing also for the runtime scenario, where you pick up basically current sensor feeds and the current image and push that into the trained model in order to get the business result. So those data refining applications, those data pipelines is a core capability in Data Hub. And these data refinery applications are being built in two ways. You can build them either with the Data Hub modeler, which is kind of a flow graph modeling capability where you have data operators, data connectors, and you draw lines and arrows in between. You can also give that to your data scientists that can play around with data, that can look at an Excel-like user interface and from there do data exploration, data scrubbing, data integration, and by push of a button turn that into a data pipeline. That's what I call the self-service data preparation. Last but not least, with Data Hub, since we are leaving data where it is, right, in the big data store and the enterprise application system, it's very important for us that we can bring the data processing to where the data is stored, right? Otherwise, you would have a lot of network traffic and that would kill the entire scenario. That's why Data Hub is running on a distributed architecture. We are using Docker's Kubernetes for that, right? So we can basically take a Data Hub pipeline, dissect it into small units that we put into a Docker's container and run in a Kubernetes landscape, right? Now, if you have such a serverless distributed execution, it's clear that you need a strong orchestration and monitoring capability. So that's piece number 3 that is required in Data Hub in order to deliver what you want to do. In a nutshell, Data Hub helps you discover big data, process big data, create results, and orchestrate data flows in a big data world across any type of data, structured, semi-structured, fully structured, across a breadth of data stores, not only SAP but also Microsoft, Google, Amazon, Hadoop, with any data processing service, open source or coming from SAP. To give you an idea of what it looks like, this is basically it from the data catalog showing you a data fact sheet. Those data fact sheets automatically get generated with any data that you connect to SAP Data Hub. We can discover semantics of data, telling you, okay, in that column, this looks like an email address, or that could be a social security number. We can also obviously detect what are top 10 distinct values, and so on and so forth, and we show that in a nice graphical way, giving you some insight how you can actually use and leverage that data. From a data pipelining perspective, I was talking about you can create a data pipeline in kind of a modeling approach. That's basically the modeler that you see. Now, when people see that for the first time, they say, well, yeah, I've seen that before. It looks like an ETL tool, extract, transform, load, right? We've been doing that in data warehousing for many, many years, right? ETL tools are in the market for quite some time. That's why I've picked like a special pipeline to demonstrate, yes, you can use Data Hub for doing like simple data integration, but normally that is not like the sweet spot. That's not what you would use it for. It's really for data refinement of rich data types coming from a variety of data sources. What we're seeing here is basically a sentiment analysis running with Twitter, right? So we have an input stream coming from Twitter. We are analyzing that in real time and basically figure out, for example, what do people post on Twitter about my latest product innovation? Do they talk about it in a positive, in a neutral, or in a negative sentiment, right? That is a kind of data pipeline that you could create. You can create data pipelines that do video processing. We're doing that with retailers that say we are interested to know not only what products our customers buy. You can figure out that information from your point of sales, right? We are interested when people walk into our store, what are the things they actually take out of the shelf, look at, and put back into the shelf, right? How can you do that? With video analysis. You have cameras in the store. Those cameras basically take a constant video feed. If you have object recognition in that data pipeline, you can determine what object you're looking at, what product is being taken out and put back into the shelf, and can provide that information to the store in order to optimize, for example, the shelf space and get more revenue out of that. Now, instead of creating data pipelines in this modeling type approach I was talking about, while data pipelines or data processing, data preparation, wouldn't it be cool if I could do that also more in a, say, end-user driven self-service mode? And we're seeing that big time in the BI analytics space for many, many years, that the way you drive innovation is changing. We're seeing that in the BI analytics space, for many years, self-service approaches are basically very, very dominating. We are moving away from classical strategy and roadmaps where you have a business case, focus, project, decision, and then a waterfall type implementation, much more to a culture of constant innovation, a culture where people try out things, right? Experiment with data, create a new report, and at some point you see, well, this thing that has been created by a user is actually very useful for the company, and we want to make it corporate standard. We want to move it from mode 2 into mode 1, right? The challenge is if you're using tools that don't integrate. I had a customer once saying, yeah, mode 1 for us is BW, Business Warehouse from SAP, right? Our data warehousing technology. Mode 2 is Google Bigtable, right? Now their challenge was whenever something great was developed in Google Bigtable and they wanted to bring it back to corporate standard BW, it was a re-implementation, right? With self-service capabilities built into SAP Data Hub and built into SAP Analytics Cloud, you can actually work with the data in a familiar Excel-like UI, right? And that Excel-like UI not only works for 100 lines, that works for millions and billions of lines, where we then use technologies like sampling, not showing the entire data, but only like meaningful samples. You have some common actions on that. You can do like show, hide columns, add formulas, cleanse the worksheet, remove duplicates, and so on and so forth. You can combine worksheets. Use case very interesting for a lot of our customers is how can I take a BW query, right, and combine this BW query with data that is sitting in the data lake or with data that is sitting in an Oracle data warehouse, through a join or through a union. You can do it here, right? And you get some data quality statistics as part of that process, and in the end you can convert whatever you created while you worked with the data, while you were processing the data, you can take that into a data pipeline or into a data flow. So you move immediately by push of a button from mode 2 to mode 1. Right? And you can use that technology, for example, for your data scientists in order to prepare the data that you use to train your machine learning models. Right? In a what you see is what you get type environment. From a solution monitoring perspective, right, since this whole engine is running in a distributed fashion, right, on Docker's Kubernetes, we provide you with some strong monitoring and diagnostics capabilities, telling you exactly, well, what parts of the infrastructure are working well, what other parts are not working well, do I have to scale up, scale out somewhere in order to get the response times, and so on and so forth. Now, what are scenarios that our customers are actually embarking on with these technology components, HANA, Data Hub in combination? I would say the leading scenario today is what I call here the intelligent data warehouse. Intelligent data warehouse, or you could also say like federated data warehouse. Whenever you have scenarios where parts of the data is sitting on the data warehouse, other parts on the data lake, and for whatever reason you cannot copy from here to there or from there to here. And those reasons are manifold, right? Agility, security, compliance, I was mentioning. I had a customer the other day that said, well, we have a data lake in our scenario, but that data lake is actually not owned by us, right? It's a shared data lake between many companies. We cannot just load data into that, right? We cannot just load data off that. We need to virtually combine that. Whenever you have scenarios where you have to do that, like Red Bull is doing that, they have data warehouse reporting on customer 360, and they enrich that customer data with artifacts like clickstream analysis information that they get from their web stores and combine that on the fly through this intelligent data warehouse scenario. A second core scenario that we're seeing is use Data Hub as a data science and machine learning management platform, where with Data Hub you can create the data pipelines that prepares your data in order to train your machine learning models, right? That creates also the data pipelines that are necessary to run those regular training processes, but Data Hub also providing those pipelines that actually take the current data and combine that or push those through the trained machine learning models in order to create the results. Right? That is typically related to the IoT scenarios, right? Data cataloging, data governance. Some customers also looking at that, maybe not leading today. Now, questions that we get is, well, how does that complement and integrate with other scenarios that we are seeing, like message-oriented middlewares where we do application integration, analytics integration with ETL type tools, right? Is Data Hub replacing those or not? We are not replacing, we are complementing. I was mentioning before that with Data Hub we drive orchestration. We drive orchestration of data, and that orchestration also includes that we can orchestrate ETL type flows, that we can orchestrate A2A type integrations. The sweet spot of a Data Hub pipeline is actually when you look at a large data diversity. You have rich data sets coming from unstructured sources or semi-structured sources. You need to combine that with enterprise data. And second area is where you have to apply intelligence to that data, where you have to combine that data with prediction with machine learning. In order to get the end-to-end scenario, quite often you have to have some data flows, ETL type or A2A type integrations. With Data Hub you can orchestrate those as well, right? But we are not replacing, but rather embracing those technologies with SAP Data Hub. So what you in the end get to is you get to an architecture that gives you data visibility. Without having data in one single place, you still understand what type of data you have. You have it cataloged, you have it basically also registered from a quality perspective. You get to data compliance by leaving data where it is, providing again a searchable catalog plus data lineage on top. You get that data compliance. That Data Hub and HANA Data Platform also provides you with loads and loads of data quality capabilities. You can do data anonymization, you can do data enrichment, data cleansing steps in those data flows, in those data pipelines. By leaving data where it is, you can drive down data costs significantly, right? You don't have to take endless copy. The data management costs will go down, and by leaving data where it is, you can also much faster actually innovate. We are leveraging those technologies also at SAP in order to build out our intelligent suite of applications. That's a very important point. We were also looking at SAP. How can we actually create intelligent applications as part of ERP, as part of customer engagement, as part of procurement applications in a scalable, repeatable, and fast way? And on the top, you're seeing basically applications that are already there, like predictive maintenance application. You also see applications that are currently in the making. Whenever such an application, and predictive maintenance is a great example, whenever such an application needs data that not only sits in SAP, but that sits partially in SAP, like the plant maintenance information and the material master clearly sitting in SAP, right? Whenever you have to combine that with big data like IoT sensor feeds, that are relevant in a predictive maintenance scenario, right? Then we are leveraging Data Hub in order to create those data pipelines. And obviously, we're using the machine learning capabilities in there as well, right? Now, from a customer perspective, KSA Compressors actually embarked with SAP on a journey a couple of years ago, turning their business upside down from selling products to selling services, right? Instead of selling a compressor machinery, what they're doing today is they sell cubic meters of compressed air, right? In order to get there, right, that has like a big impact on how you operate, how you run your machine. So what service level can you provide and how quick you can fix things if things break. And by combining IoT data with supply chain data, apply machine learning on that, that is giving KSA Compressors basically the insights that they need in order to drive those scenarios forward. Now you might have heard, listening to SAP announcements lately with TechEd happening right now, the term data intelligence as well, right? So let me explain what that actually is and how Data Hub and Data Intelligence and Machine Learning Foundation, how these bits and pieces actually fit together. Basically what we've done is we take Data Hub and we combine that with the machine learning technologies that we have in our HANA foundation, that we have as engines in the HANA platform, and we create a single product out of it called SAP Data Intelligence, right? Now, as we speak today, right, Data Hub, Data Intelligence are separate products still, but they will merge in the next 3 months into a single product, single code line, and we take it forward under the brand SAP Data Intelligence. So you should not be surprised if in a year from now you would not hear SAP Data Hub any longer. Having said that, right, everything so far was very much focused on our on-prem architectures, on-premise delivery models. We are taking all these technologies also to the cloud. SAP Data Intelligence already today running on cloud. SAP Analytics Cloud, our analytics front-end component, developed completely in the cloud. What we released just now, also at TechEd, is a data warehouse cloud application based on SAP Cloud Platform, supporting multiple cloud infrastructures from different vendors, Amazon, Google, Microsoft, running there, providing you with a data warehouse solution in the cloud, running on top of HANA, which is also taken to the cloud. Right, those three parts: Analytics Cloud, Data Warehouse Cloud, HANA Cloud, right, provide you a single gateway, basically, to all your trusted data. We refer to that as HANA Cloud Services. Now, the cool thing is that Data Warehouse Cloud works nicely integrated with HANA on-prem, with BW4 on-prem. Right, we've developed it in a way that it does not replace but complement. So some customers basically take the decision: we want to go full steam into the cloud, right? So as quick as possible, transfer everything we have in BW to Data Warehouse Cloud, right? Other customers decide, well, we want to have a side-by-side scenario where large portions of our data, like the enterprise governed BI competency center driven data, sits and resides in BW on-prem, right? But we want to provide innovation spaces to our line of business, Mode 2 development for data marts, right? How do you do that? Data Warehouse Cloud, sitting next to a BW on-prem, providing you innovation spaces for your users, right? So that's basically the way forward. You can basically embrace the cloud at your own speed. If you want to go forward full steam, right, you have everything in the cloud as of today. If you want to have a gradual roadmap where you take parts that you have on-prem slowly to the cloud, or if you have a roadmap where you say certain capabilities that I'm lacking in my on-prem, I want to have in the cloud with the offering that we have across HANA and HANA Cloud Services and Data Intelligence, you can basically do that. With that, I want to end this little presentation and open it for questions. Okay? All right. Thank you. Enjoy your lunch.